Hello, it's Duncan. Since we decided to use Jooq instead of Exposed as our SQL mapping library, we had the problem that Jooq is database first. It generates code from the database rather than the database from code. But how do we set the database up in the first place? The grown-up way of initializing and modifying a database schema is to use migrations, a system that describes changes and automatically applies those that are outstanding. So today we'll work out how to set up our database with Flyway. We left the last episode with the realization that we were still using Exposed to create our schemas. So reset DB when we were testing Exposed was creating the missing tables and columns for our database items. And we have no way of doing that at the moment for Jooq, so we can't remove the Exposed code. The recommended way of managing schemas is to use migrations, and we're going to use something called Flyway. Here's its documentation. You can see it has a Gradle plugin, and we write migration files that describe steps to build a database. First of all, creating tables and then modifying tables if you want to, and so on. So let's take this code, probably these two bits, and put them in our Gradle file. So I'm going to paste them in here and then distribute them. So we've got another plugin to go into our plugin block. So I can delete that. And Flyway is its own configuration. So let's take that out of there and put it down the bottom, maybe before Jooq, because logically it runs before Jooq. And now we need the same sort of configuration for Flyway as we did for Jooq, because it's going to talk to our database as well. So looking here, it looks like we can give it a URL, a user, and I guess we'll need a password. So let's put those into there. Now we'll import the Gradle changes. And now let's go back to the documentation. And this says we need to create a migration file somewhere. So let's remember something like that. Go back, and on the command line, I'm going to make a directory in that place and create a file like that one. And we don't want to create the person table, we want to create the item table. Good. And now in source main resources, we have our file. IntelliJ is offering to be clever, so I think we can say change the dialect to Postgres. Back to the documentation. Now this gives an example of the sort of data definition we want, but obviously that's not what we actually want. But I think we might ask Postgres to tell us what Exposed had asked it to do. Back again. And now in the database here, we can go to the items table and we can say SQL scripts and then generate DDL to query console. That might be useful. Let's have a look. And here we are. It's worth just seeing how Exposed got there. So here on the left, you can see what we told Exposed our data should look like, and on the right, what it's generated. So our varchars come from here into here. The not nulls come from the fact that these are non-nullable types in here. So but it is not null because it's nullable in here. And because we said there should be an index on our modified column, it creates an index in here. Okay, we know that Jooq is happy to work with the table like this. So let's copy this and put it into our migration file. So that's that one. Back once more to the documentation, and it says we should call Gradle Flyway migrate, and this -i I think is just logging. So let's take that back to our command line, and we will execute in fact /gradlew and see what we get. Okay, that's failed, and it says failed while executing Flyway migrate, found non-empty schemas public but no schema history table. Use baseline or set baseline on migrate to true to initialize the schema history. I don't really want to do any of that, but what I think I might do is just nuke the database from here for now and see what we get. So I can go to these tables and delete them, drop them in back, and now try again. And that apparently is successful. We'll refresh in here. Now we can see we have two tables. One is our items table that we expected, with the one index and the columns from this DDL. And the other is a Flyway schema history that records in the database what migrations have been applied. And in this case, we expect there to be one. In fact, if we drill down into this, we can see there it is, installed rank, version 1. It was create item table from a script. So just to recap, we now have Gradle tasks provided by two plugins. Flyway is populating the database, and Jooq is reading the database that's just been populated in order to generate some source. It seems at the moment we're having to manually run the Flyway migrations before we run Jooq. I'm sure there's some way of making that work automatically in Gradle, but for now I think we'll just put up with running it manually when we know something has changed. I also believe that there's some way of pointing Jooq directly at the migrations so that it doesn't actually have to talk to the database at all in order to generate its sources. I'll investigate that later because I'd like to make some progress on other things now. This feels like a place that we could check in, so let's go here. And we created that by hand, so we need to add it to VCS and then select it, and then this is introduce Flyway. Oh, that was quite painless. Now we have Flyway, we don't need exposed to generate the schema for us, so let's go and remove some exposed code. Quite a good way of doing that is probably just to remove the import and see what happens. So that is up here, so we've got exposed, exposed, exposed. That means I think that this exposed version can go, and now if we import that and rebuild our project, find that database items can be deleted. Let's just do the whole file, build again to chase it out. Now again we seem to have crashed the compiler, don't know what that's about, but let's go to our, we know we've got database items tests. So that's all in trouble, but we don't need it anymore, so we will do delete, build again. Compiler still unhappy. These issues are, I think, because we opted into the experimental context receivers. I'm going to search in our project for exposed. So we have a package, and then we have test database.kt. It looks like we could get rid of that. Find again. And now we have a file here of PG items tests. Okay. And that was our very first experiment with exposed that can also go. Try and build that. And that's a bit better now. We'll run on our tests. And we're back on stable ground. So we can commit that as remove exposed code. We seem to have some issues here all around our build.gradle, which still amazingly seems to work. But ignore that and think what to do next. Now that we're committed to Jooq, I think it would be good to tidy up Jooq items. There are a couple of issues here from my perspective. One of which is that it's too easy to use the wrong DSL context. We had this transactional DSL context from the context object here, so many contexts, and we had the DSL context that we're provided with in the first place, which we then make transactional to pass to this block that provides this transactional context. It would be too easy to use this DSL context. So what I want to do is sort of hide it, and the way I'm going to do that is to put it inside an object. So we're going to take this thing as a constructor parameter and say we have this private val, and I'm going to call it for in transaction, so we know why, and I'm going to say it's an object that has a single property, which is a val, and we'll call it untransactional DSL context, and we'll assign that here to the constructor parameter. And now inside here, instead of taking this DSL context, we'll look into for transaction, and we'll say untransactional DSL context, transaction result. And the point of that is that inside a method like this, you can't access DSL context anymore. Well, we can, but in fact, it's the test version here. Let's rename that so we're not confused. This is going to be test DSL context. So that would give some clues. If we were here, we can't see this one. And now we've done that, I think that we can rename this thing to be just DSL context. So we'll make it that the easy path, the simple thing, is available to you. And there's a warning here. It says it's the same as DSL context and could be inlined. Don't know what happens if I do that. Oh no, that was the very opposite of what I wanted. But it looks as if we're going to have to say suppress unnecessary variable for that val. Maybe just inside there. Run the tests. Now, I might not always be as fastidious about this, but this feels like one of these places that I might mess up in the future when I don't remember what we did here. Commit that change as hide non-transactional DSL context. Good. And now further down here, A few places we can tidy up. So first is we're referring to these items here, here, here. That's a bit of a shame. This is actually a field, a static field of our items class, but it's sort of polluting this. So I think we could say in here with items and then put that block around this lot, and that would allow us to take out all these items dot, which simplifies things a bit. It's tempting to use insert into this, but I think probably items is clearer. So let's run that. Good. Now this insert into syntax is like SQL, but we had the problem that ID is separated from the value, the modified is separated from its value, and so on. And Lucas was hinting that there was a better syntax, which is set. And in a set, we can take one of these things and then the value that we want. So we could take that. And we can chain those. So let's go ahead and do that. So we'll also set, and we'll delete them as we go. So that's modified. Maybe, and we'll just lay this out a little nicer. Check that does actually do the right thing. Good. And now there's a few little places in here. This item ID value is because we need a string in the end. We have ID wrapped a non-blank string which has a value. But in this case, actually, this is ID to string. And the same is true here. So that name to string, run that. And I think you'll agree that's quite a bit nicer. It could be made even nicer if we made this a when up here so that it's a little bit clearer. So the thing we're going to save is when the stock list is empty, it's a sentinel item, otherwise it's all the items, and then we save. Well, I think of it, we had this issue here, this item sell by date is actually nullable. And I'm not sure we're actually testing that in the case of this code. So I'm going to go to the contract, which is this one here. You can see we have two items that have different dates, but neither has null. So I'm going to try putting null in there just to make us a little bit more honest, check everything is working. Run all the tests again. Good, and while we're thinking of fixing things, we can make these private. Wonderful. Back to Jooq items. I think when we load, we can do a similar sort of thing with, which is to say, in here we can say with items, put it in the brace and tuck that all around there so that all of our items dots become a receiver. I think that's the lot. Take them away and run. Good. Now we have some horrible names and types here. This list of pair of instant item and getting the first one null and getting the second one or the first one and so on. To be honest with you, I was a little bit flustered when I was trying to work this out with Lucas. So let's see whether we can better. I think the first thing would be to extract the result of this select from the map. So we make a variable out of that. Then these are our records. Now, I think the first thing I want to do is say, instead of mapping over them regardless, I think we could probably say in here that if records is empty, then we should just return. And the thing we're going to return is this stock list with our instant epoch because we have nothing saved, and with an empty list because we have no items. We just check that logic works out. It passes the test, that's good. And now we know we don't have an empty record, and we also know that every one of these records has the same value for modified, which will be the last modified of our stock list. So again, before we map, we can say that our last modified is our records first, which we know must succeed because we checked whether it was empty here, and then we can go and map with modified in there. And if we write the type of that will be our instant. That's good. And now we don't need to map to a pair here. So now this can just be our items, which will be a list of item. It's our records mapped with record to item. That means we can tighten this up and this can just be it. Now we've got our items. We say if our items single or null equals our sentinel, well, that defines whether we saved any items. That's going to be val is empty. And I guess we can just take out that. And so now we can get rid of that and that. And we can say we return a stock list with the last modified, and if it's empty, an empty list. Otherwise, our items. Run to see whether we're right. And now we can tighten everything up a lot here. So we can make that into one line. We can make that into one line. And this early return here, I don't normally like early returns, but this is what we call a guard clause. It's guarding the rest of this code from what happens in this exceptional circumstance. The alternative is to put an else in here, pick a block around all that, and then we should be able to lift this return out of the if. Don't quite know why we can't. Do it by hand. That will say that, and then I think it might be nicer, so let's commit. This is ID out Jooq items. Grand. Before we finish here, there's one more thing I'd like to look at, and that's these errors. The problem here is that we know that our ID can't be blank, and that the name can't be blank, and the quality has to be greater than or equal to 0. But inside our database, we can have blank strings or negative numbers. It would be nice if that wasn't the case. It would be nice if our database schema enforced these constraints. So these errors really would be logic errors as opposed to something that might happen reasonably with our database at the moment. So let's go over to our database console and have a little play. So that's this query console here, and we'll open the default one. And I'm going to move that over here so we can see two things at once. So first of all, let's try inserting some invalid items into our database. So we can say insert into items. We'll list of the things we want. So that's those things. Thank you, IntelliJ. Tuck that away so we can see them all. Values, and now a list of the values. What do we want? Well, let's put some valid values in to start with. So we'll put in ID. Modified, we can use now as a function inside the database. Name, we'll put name. Sell by date, we can use null, I think. And the quality, we'll put 42. And who knows how to lay out SQL? I certainly don't. Something like that, maybe. Let's try running that. Oh, and I messed up because I put in the wrong quotes ID like that, I think. Try again. And that has succeeded, I think. Now then, let's try and put in a blank ID. That's that. And that was fine. That's what we'd like to avoid happening because we believe it really is part of our domain that IDs can't be blank. So how do we prevent that? Well, we can add a constraint. So we can take the table we've got at the moment and we can say alter table items, add check. And here we can say that we don't want the ID to be an empty string. Let's try running that. And down here we see check constraint items ID check of relations item is violated by some row. So the fact that we ran this now means that we can't alter the table because it has an item in it that breaks that constraint. Well, that's nice and might save us at some point. Let's truncate the table so we don't have that problem. So we'll say truncate table items. That will get rid of all the data in it. Now we should be able to run the alter to add the check. That succeeds. And now we shouldn't be able to add an item with a blank ID. And there you see, new row violates the check constraint. So we could go on and we could add other checks. We could check that the name is not blank. And we can check that the quality is greater than or equal to 0. Add that check. Succeeds. Add that check. Succeeds. And now if we were trying to put minus 42 in there, but with an ID, that would fail our items quality check. Okay, so now we have a way of changing our schema to make it more correct. We can add that into a migration. What we're going to do is we're going to take that, we'll go over to the project, and we're going to create a new file. And v2 is important because Flyway populates these in version order. So this one is going to be, I think there's 2 underscores there, add constraints to item. And it's SQL. We want to add that. And now in here, we add our statements. And now to check that all does work, I'm going to go to the database and I'm going to delete all the tables. So I'm going to drop that there. And then we'll bring up the console and we will run the Flyway migration. That's happened. Now back to our database console. It's here. And let's try running this. And you can see that we do have the constraint because that insert has failed. I must say there's something in me that would really like to find a way to express this check here because this is a non-blank string and this check here because this is an ID and so on. But the philosophy of Jooq is, I think, quite sensibly database first. So there's always going to be a little bit of an impedance mismatch potentially there. Also, it's not a problem for us at the moment because we don't have a production database. But every time we add a migration, we have to arrange for that to be applied to the production database. That means that Flyway is going to be involved in our deployment process, either manually or automatically. But that's another bridge I think we'll cross when we come to it. For today then, let's check in. And this is add item constraints in DB. Talking of migrations, we still currently have our stock data in this tab separated stock file. We're going to need to find a way to migrate our data from that file into the database. We'd like to do that in a controlled, safe manner, preferably without downtime, which I suspect will mean running both of them in parallel for a while, relying first of all on the stock file items and then on the Jooq items. We'll start that job next week. If you'd like to see that episode, then please subscribe to the channel. And if you enjoyed this, then I think you'll enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.